An army, Napoleon Bonaparte once said, marches on its stomach. Even on today's high-tech modern battlefield, wars are lost and won not by rifles, missiles, tanks, or jet fighters, but by logistics. The ability to get supplies like food, ammunition, fuel, and medicine to one's troops as quickly and as reliably as possible. And few battles throughout history have hinged more on efficient logistics than Operation Overlord, the 1944 Allied invasion of Normandy. After securing the beachhead, the Allied forces quickly thrust inland to prevent the defending Germans from regrouping and pushing them back into the sea. But a modern mechanized army is a thirsty beast, and the tens of thousands of tanks, trucks, aircraft, and other vehicles involved in the Normandy breakout needed massive quantities of fuel to keep them pushing forward, fuel that could not be delivered quickly enough by conventional means. Thankfully, the Allies had a secret weapon, a feat of logistical engineering unmatched in the history of amphibious warfare. This is the story of Pluto, the secret underwater pipeline that fueled D-Day. When planning for Operation Overlord began in earnest in early 1942, the challenge of fueling the massive invasion force was of the utmost concern. Initially, it was planned to deliver fuel using conventional coastal tankers, such as the American 600-ton Y-type or British 400-ton Channel tanker or Chant. However, such vessels required harbour facilities to offload their cargo, and it was uncertain when those would become available. Indeed, the disastrous Dieppe raid of August 19, 1942 demonstrated to Allied planners the extreme difficulty of capturing a well-defended port from the sea. This was why Operation Overlord targeted the more open and weakly defended beaches of Normandy instead. And even when nearby ports like Cherbourg or Le Havre were eventually captured, it was likely the Germans would sabotage the harbour facilities, preventing their use for weeks or even potentially months. Thus, in the early stages of the invasion, fuel would be delivered directly to the beaches by landing craft using some 20 million 44-gallon oil drums and 5-gallon jerry cans. To manufacture the vast quantity of containers needed, an entire manufacturing plant was shipped from the United States and erected outside London by the British Ministry of Supply. And to learn more about the surprisingly clever engineering of the humble jerry can and the outsized role it played in the Second World War, please do check out our previous video, The Forgotten Metal Can That Made Blitzkrieg Possible and ultimately won World War II, when the Allies stole it. Once the beachhead was secured, fuel could then be transferred in bulk from the 9,000-ton T2 ocean-going tankers anchored offshore through short submarine pipelines codenamed tombolas. But this was far from an ideal solution, for such tankers and pipelines could potentially clutter up the invasion beaches, hindering the delivery of other supplies. They were also vulnerable to the often unpredictable weather of the English Channel, as well as to attack by German aircraft and U-boats. But in April 1942, Lord Louis Mountbatten, Chief of Combined Operations in charge of logistics for Overlord, approached Geoffrey Lloyd, British Secretary for Petroleum, with an intriguing proposal. Would it be possible, he inquired, to lay a submarine pipeline directly across the English Channel from southern England to Normandy? Such a pipeline would be far less vulnerable to weather and enemy action than tankers, and would allow the vast quantities of fuel to be delivered to the invasion force more quickly and efficiently. As luck would have it, the necessary supply infrastructure on the English side was already under construction. As storage tanks on the Channel coast were vulnerable to enemy attack, the British moved the tanks west to Bristol and Liverpool and connected them via overland pipelines to ports and airfields across southeast England. Known as the Government Pipelines and Storage System, or GPSS, this network still exists today, and it's operated by the Spanish multinational Exolum. Intrigued by Mountbatten's proposal, Lloyd consulted with various experts, including Brigadier Sir Donald Banks, Director General of the Petroleum Warfare Institute, geologist George Lees, and Sir Arthur Charles Hearn, oil advisor to the 4th Sea Lord and Chief of Naval Supplies, Vice Admiral Sir John Cunningham, and the former director of the Anglo-Iranian Oil Company. Their assessment was not encouraging. While short submarine oil pipelines were widely used in port facilities, none had been laid over such a span as the English Channel. Furthermore, to avoid the difficulties posed by changing tides and enemy attack, the pipeline would have to be laid across the channel in a single night. This would require a pipe with a diameter under 6 inches, too small to supply the volumes of fuel required. As far as Banks, Lees, and Hearn were aware, the technology did not yet exist to carry out Mountbatten's proposal. But, as luck would have it, at the time this discussion was taking place, one Clifford Hartley, chief engineer of the Anglo-Iranian Oil Company, happened to be visiting the Petroleum Warfare Department. On hearing of Mountbatten's proposal, he was immediately convinced that it could be made to work. Indeed, the Anglo-Iranian Oil Company was already using 3-inch flexible pipeline to carry oil across the mountainous Persian terrain, operating at a pressure of 1500 psi or 10 megapascals. Such pipelines could carry the equivalent of 100,000 gallons or 450,000 liters per day. On April 15, 1942, Hartley submitted a proposal for a submarine pipeline similar in design to an undersea communications cable. At that time, a well-established and understood technology, constructed from multiple layers of rubber and metal cabling to withstand the pressure of the oil inside and protect it from damage. Such a pipeline could be deployed in one continuous roll using a conventional cable-laying ship with multiple pipelines being laid to increase delivery capacity as needed. As in Iran, the system would be operated at high pressure, not only maximizing flow rate through the narrow pipeline, but also allowing different kinds of fuel like diesel, lubricating oil, and high-octane aviation gasoline to be transferred through the same line. At low pressures, such fuels would mix, but at high pressures, they remain separate. Seeing merit in the idea, Combined Operations gave Hartley the go-ahead to develop his design, the development work being bankrolled by the Anglo-Iranian Oil Company. Significant contributions were also made by electrical engineering firms Siemens Brothers and Johnson & Phillips, tire manufacturer Pirelli, the National Physical Laboratory, and the Post Office, which ran the UK's telecommunications network and had extensive experience with laying submarine cables. Together, these organizations developed a flexible 2-inch pipeline codenamed HACE after its main inventors, Hartley Anglo-Iranian Siemens. Effectively a submarine communication cable without its conductive core, the pipeline consisted of an extruded lead tube wrapped in successive layers of asphalt, resin-impregnated paper, steel tape, jute tape, asphalt-impregnated paper, woven steel wires, and canvas. This could withstand 500 psi or 3.4 megapascals of internal pressure and 1,950 psi or 13.4 megapascals of external water pressure and deliver up to 3,500 gallons or 16,000 liters of oil per day. Research and development was completed in record time, and on May 10, 1942, a 360-foot or 110-meter prototype span was laid across the River Medway by the Royal Mail cable ship CS Alert. Oil was then pumped through the line using pumps borrowed from the Manchester Ship Canal Company. At first, the system appeared to work perfectly, but after 2 days of pumping, the line pressure suddenly dropped. The pipeline was duly raised and inspected, whereupon it was discovered that the high internal pressure had extruded the lead core through the gaps in the reinforcing metal tapes, causing the pipe to fail. The tape layer was thus doubled in thickness, and subsequent tests, carried out in June across the Firth of Clyde in Scotland, were more successful. However, the Clyde trials revealed that the soft lead pipe had to be kept pressurized with water at around 100 psi or 700 kilopascals to prevent it from distorting or collapsing. Thus, during manufacture, the pipe sections were fitted with copper burst discs that could withstand this storage pressure, but would fail when the pipeline was pressurized to working pressure, allowing fuel to flow freely through the line. Sections were joined using special split-ring muffs designed by lead burners Frank, Albert, and Ron Stone, who, working 18 hours a day for 2 years, would go on to manufacture some 1,300 of these joints. Soon after the Firth of Clyde trials, the submarine pipeline project was officially approved by Combined Operations under the code name Pluto, short for Pipeline Under the Ocean or Pipeline Underwater Transportation of Oil. The overall project was placed under the command of Section G4 of the Chief of Staff to the Supreme Allied Commander, or COSAC, under the direction of British Army Major General Neville Brownjohn. Responsibility for the pipe-laying operation was given to Royal Navy Captain John Fenwick Hutchins of the Admiralty's Department of Miscellaneous Weapons Development, aka the Wheezes and Dodgers. And to learn more about this eccentric organization and the many ingenious and bizarre weapons it developed during the war, please do check out our previous videos, World War II's most absurd secret weapons and the hilarious World War II attempt to replace parachutes with rockets. As an interesting side note, at around the same time, the United States Army was also developing a scheme for a cross-channel oil pipeline. This plan called for lengths of 6-inch diameter steel pipe to be welded together onshore to form pipeline segments 6 miles long. These segments would then be towed out to sea and sunk at precise points aided by radar location, whereupon Navy divers would join them using special flexible joints. However, in December 1943, this scheme was abandoned in favor of the more elegant and feasible Pluto. Full-scale production of HACE pipeline began on August 14, 1942, at numerous facilities including Glover's Cables in Manchester, Callender's Cables in Erith, and W.T. Henley in Tilbury. At full capacity, each of these facilities could extrude, wrap, weld, and pressure test up to 4.3 miles or 7 kilometers of pipe per day in lengths measuring 4,000 feet or 1,200 meters long. To give an idea of the sheer scale of the project, each each mile of pipe used 24 tons of lead, 7.5 tons of steel tape, and 15 tons of steel wire. By the time D-Day arrived, the Tilbury facility had consumed over 8,000 tons of lead and 5,600 tons of steel. On October 30th, 1942, 30 miles or 50 kilometers of Hays pipeline was loaded aboard the cable ship HMS Holdfast, formerly the civilian cargo vessel Empire Tor, and on December 29th laid across the Bristol Channel between Swansea and Ilfracombe. Despite rough weather, the operation went smoothly, though soon after the pipeline suffered minor damage from a pair of German aerial bombs and a ship's anchor. However, the cable was quickly raised and the damage repaired. Subsequent pumping tests were equally successful, with the pipeline delivering up to 56,000 gallons or 250,000 liters of oil per day at a pressure of 1500 psi or 10 megapascals. Based on this success, Siemens decided to develop a larger 3-inch diameter pipeline, which, thanks to the magic of geometry, could carry more than twice the flow rate of the earlier 2-inch pipe. To lay this larger pipe, 3 cargo ships, HMS Sancroft, HMS Latimer, and HMS Algerian, were fitted with large 50-foot or 15-meter storage drums forward and aft. 5 Thames River barges, Britannic, Oceanic, Runic, Gold Dust, and Gold Drift, were also acquired to join the ends of the pipelines to pumping and receiving facilities, as the larger cable-laying ships could not operate close to shore. In total, 710 nautical miles, or 1,310 kilometers, of Hays pipeline were produced, of which 570 nautical miles, or 1,060 kilometers, were manufactured in the UK, and the rest in the United States by firms such as General Electric, Phelps Dodge, and General Cable. However, just as full-scale production was getting underway, supplies of lead for the pipeline core began to run low. The Petroleum Warfare Department thus decided to develop a backup design using more readily available materials. The resulting pipeline, codenamed Hamel after its inventors H.A. Hamel of the Iraq Petroleum Company and Bernard Ellis of the Burmah Oil Company, replaced the lead core with one made of 0.2-inch or 5.4 millimeter mild steel. But while cheaper to manufacture than the Hays pipe, Hamel was also harder to join together. But a solution was eventually found in the form of flash welding, in which the 2 sections of pipe were held a short distance apart and a powerful electric current passed between them, creating an arc that melted the exposed ends. These ends were then pressed together to weld them, and a special broaching tool used to clean out the inner bore. Initially, prototypes were constructed by J&E Hall, a manufacturer of refrigeration equipment, while full-scale production took place at Tilbury near the Hays Pipeline factory, in a facility designed and built by tube and pipe manufacturer Stewards and Lloyd of Corby, Northamptonshire. The machinery needed to produce the Hamel pipeline was highly specialized and impressive, as historian Richard Cleland described in 1952. Special machinery was designed, built, and installed to perform all manufacturing operations simultaneously. Armoring and covering machines, each stretching over a distance of 160 feet, applied all the many separate layers of protective coverings in a single continuous operation, thus producing the pipeline in the required lengths and at high speed. A specially designed superstructure, 90 feet high, then carried the pipe to large outdoor platforms where it was coiled preparatory to loading into specially converted cargo ships alongside the plant docks. One such coil, 50 miles long, weighed about 4,000 tons, a weight greater than the tonnage of 2 United States destroyers. In order to prevent the coiled pipe from being crushed by its own weight, it was kept filled with water at all times. Another downside of the Hamel design was its lower flexibility, which meant it could not be rolled up in the holds of regular ships. Instead, the Petroleum Warfare Department designed giant, buoyant steel drums, 40 feet or 12 meters in diameter, 60 feet or 18 meters long, and weighing 250 tons, which could be towed behind a ship or mounted on a barge. Being cone-ended, they were initially known by the abbreviation Conan, although this was later changed in typically cheeky British fashion to Conundrum. 6 of these devices were built at a cost of £30,000 apiece, more than £1.7 million in today's money. They were christened HMS Conundrum 1 through 6. A special dockside fixture was also built with 2 arms that would hold and slowly rotate each conundrum, while 4,000-foot or 1,200-meter pipe segments were slowly wound around it and joined together. In total, each conundrum could carry 90 miles or 140 kilometers of pipe. To tow them across the English Channel, 3 powerful Royal Navy rescue tugs, HMRT Bustler, Marauder, and Danube 5, were pressed into service. To test out the concept, a conundrum was mounted atop the Admiralty barge W-24, which was rechristened HMS Persephone. And yes, for all of you classical mythology nerds out there, Persephone is indeed the wife of Hades, ancient Greek god of the underworld, or as the Romans called him, Pluto. The first scale test of the Hamel and conundrum system took place on June 4th, 1943, almost 1 year to the day before the actual Normandy invasion, when HMS Persephone laid 16 pipelines across the Solent between Portsmouth and the Isle of Wight without major incident. In light of the success, it was decided to use both Hayes and Hamel pipelines in the coming invasion. Meanwhile, the GPSS pipeline network was extended to 2 pumping stations on the Channel coast, which, in keeping with the Disney theme, were codenamed Bambi and Dumbo. The Bambi pipeline would run from Sandown on the Isle of Wight to Cherbourg, while Dumbo would run from Dungeness to Boulogne across the narrow Dover Strait. Each pumping station contained 30 diesel and 4 electric pumps capable of moving 400,000 gallons or 1.8 million litres every day. Construction was carried out under the strictest of secrecy, with work taking place only under the cover of darkness. The name, or even initials, of the Petroleum Warfare Department could not appear on any letters or packages, nor the sites of the pumping stations on any maps, while all planners or workers were forbidden from using the word pipeline, with cable being preferred. And to disguise their purpose, the pumping stations themselves were disguised as various everyday structures, including seaside cottages, amusement parks, gravel pits, and even an ice cream parlor. Meanwhile, a dummy oil dock was built at Dover as part of Operation Bodyguard, the massive deception campaign to fool the Germans into thinking that the invaders would land at the Pas de Calais. And to learn more about this enormous and enormously creative undertaking, please do check out our previous video, The Bizarre Story of the Massive Fake Army that Defeated the Nazis and Helped End World War II. Designed by architect Basil Spence, the elaborate facility covered an area of over 12,000 square meters and featured phony versions of storage tanks, pipelines, jetties, anti-aircraft emplacements, and other equipment built from scaffolding, canvas, fiberboard, and sewage pipe. To complete the deception, the installation was guarded round the clock by military police and obscured by a smokescreen during the day. High officials, including King George VI, Allied Supreme Commander General Dwight D. Eisenhower, and British General Sir Bernard Montgomery, even inspected the site and spoke to the phony workers. Preparations for Operation Pluto were completed by May 1944, just in time for the Overlord landings on June 6th. According to the original invasion plan, Cherbourg was supposed to be captured within 8 days of D-Day and reopened 3 days after that. The Bambi pipeline was to be laid starting on D+15 and the whole system made operational by D+75. However, due to unexpectedly stiff resistance, Cherbourg was not captured until June 27th and not reopened until July the 25th, thanks to extensive sabotage by the retreating Germans. In the meantime, Chant coastal tankers began offloading their cargoes at the small port of Port-en-Bessin. However, these small craft fared poorly in the rough weather of the English Channel, and by the time Cherbourg finally became available, 16 had been severely damaged by heavy seas and were laid up in England undergoing repairs. Oil was also offloaded from larger tankers to Port-au-Besson and nearby Ster, and nearby Saint-Honorine via the short Tombola pipelines, which became fully operational on July 14th. However, these pipelines had an annoying habit of breaking, meaning that for the first 2 months of the invasion, the vast majority of the Allies' fuel supply was delivered directly onto the beaches in the forms of drums and jerry cans. Given these difficulties, the Overlord planners seriously considered cancelling Operation Pluto altogether. However, they ultimately decided to proceed anyway, in case a backup fuel supply was needed, and on August the 12th, HMS Latimer laid the first length of Bambi pipeline between Dungeness and Cherbourg in only 10 hours. While the laying itself went smoothly, an escorting destroyer accidentally caught the pipeline with its anchor and damaged it beyond repair. HMS Sancroft tried again on the 14th, but this time the pipeline became tangled in the propeller of HMS Algerian and was also irretrievably damaged. On August the 27th, another attempt was made using the alternative Hamel pipeline design, but this too ultimately failed, this time due to an accumulation of barnacles on the bottom of the conundrum that prevented it from rotating. The Pluto crews scraped these off and duly tried again, but unfortunately the pipeline broke after 54 kilometers had been laid. As Brigadier Sir Donald Banks of the Petroleum Warfare Department later wrote, quote, "The technique of cable laying has been mastered, but we were not yet sufficiently versed in the practice of connecting the shore ends, nor in effecting repairs to the undersea leaks which were caused fairly close inshore through these faulty concluding operations." End quote. Finally, on September the 22nd, 1944, D-Day plus 108, the Pluto crews succeeded in laying and connecting a complete span of Hayes cable, which soon began carrying 56,000 gallons or 250,000 litres per day. 1 week later, a second Hamel pipeline was successfully laid. However, only 4 days later, on October the 3rd, a faulty fitting on the Hayes pipeline broke while the Hamel line was sliced open by a sharp edge on the seafloor. With both pipelines rendered inoperative, the decision was made to shut down Operation Bambi. Over its mere 11 days of operation, the pipeline carried only 935,000 gallons, or 4.25 million litres of fuel. Attention thus shifted to the much shorter Dumbo pipeline between Dungeness and Boulogne, which commenced operation on October 26th. The original plan called for the pipeline to be landed at Amphibious, but as the beach was found to be heavily mined, it was instead laid directly to the outer harbour at Boulogne. The steel Hamel pipeline proved challenging to handle, but the Pluto crews solved this problem by splicing sections of more flexible Hayes pipeline to the ends and running these ashore. By December, 17 pipelines totaling 500 miles or 800 kilometers had been successfully laid along the Dumbo route, which at its peak capacity carried 408,000 gallons or 1.85 million liters of fuel every day. As Boulogne had poor rail facilities, the pipeline was extended overland to Calais, from where the fuel could be more easily shipped to the front. While Pluto was initially intended as a temporary measure until larger oil tanker terminals could be captured, circumstances saw its life extended again and again. For example, by December 1944, both large and small tankers were regularly delivering 942,000 gallons, or 4.28 million litres of fuel, via the Belgian ports of Antwerp and Ostend, more than twice the capacity of the Dumbo pipelines. However, at this time, Antwerp was under constant attack by German V-1 and V-2 missiles, while the smaller coastal tankers were urgently needed in the Far East. The decision was thus made to keep Dumbo operational. Indeed, the overland pipeline system was continuously expanded as the Allies advanced across Europe, from Boulogne to Antwerp, Eindhoven in the Netherlands, and finally Emmerich in Germany's Rhine Valley. By the time the system was finally closed down on August 7, 1944, the day after the first atomic bomb was dropped on Hiroshima, it had carried over 180 million gallons, or 820 million litres of fuel. However, the hardware had not been without problems. While none of the Hayes pipelines ever failed, the more fragile Hamel pipelines had to be repaired on average every few months and could not be operated at their full design pressure, limiting them to carrying only one type of fuel. As no post-war use was envisioned for the Pluto system between 1946 and 1949, the majority of the pipeline was salvaged and sold for scrap, recovering around £400,000 in net value. The pumping houses were also stripped of their equipment, though many of the original structures were left in place. For instance, one former pumping house in Sandown on the Isle of Wight is now used as a miniature golf course, while another in Dungeness is now a guest house. Along with the portable Mulberry artificial harbours, which allowed the Allies to rapidly land supplies before a proper port could be captured, Pluto was one of the great technical triumphs of Operation Overlord, with Winston Churchill praising the system as a, quote, wholly British achievement and a piece of amphibious engineering skill of which we may well be proud. And historian Michael Poston described it as, quote, strategically important, tactically adventurous, and from the industrial point of view, strenuous. However, professional assessments of the project's success were more mixed. It is estimated that between D-Day on June 6, 1944 and VE Day on May 8, 1945, some 1.72 billion gallons or 7.85 billion litres were delivered across to the Allied expeditionary forces in mainland Europe. Of this, only 181 million gallons or 822 million litres, around 10%, were carried by both Pluto pipelines. Meanwhile, the entire project had cost an estimated £4.5 million, around £2.6 billion in today's money. As historian Derek Peyton Smith wrote in his 1972 book, Oil, A Study of Wartime Policy and Administration, quote, Pluto contributed nothing to Allied supplies at a time that would have been most valuable. That is, when no regular oil ports were available on the continent and the Allies were relying on the unsatisfactory ports en passant. Dumbo was more successful, but at a time when success was of less importance. End quote. Nonetheless, Pluto remains an impressive engineering achievement and a testament to the enormous lengths the Allied forces went to in order to secure final victory in the Second World War. Thank you for watching.